Push that rock with some math. Let's solve some equations. Here we have an equation. It looks quadratic and it's equal to 0. That's good. Usually we want it equal to 0 so that we can use quadratic formula, but this one isn't in standard form. It's in vertex form. That's interesting. I think in this case, we could expand this binomial, get simplified down to standard form, and then use quadratic formula. But I think in this case, it might be advantageous to take advantage of the fact that it's in vertex form. Notice if I subtract the 100 over here, let's do that. So we'll have this equal to negative 100. Now that's very counterintuitive because normally when we have a x squared, we want it equal to 0. But let's just try this. We can always reverse our steps. Now what I'm going to do is multiply both sides by negative 400. And this negative times a negative is a positive, and then those go away. And so I just have the x minus 2,000 squared. And then, anytime you multiply a number like 400 by 100, well, you just add 2 zeros. So that's no big deal. We have 40,000 over here. And notice a negative times a negative is positive, so it's positive. And that means I can take the square root of both sides. I can take the square root of this left side and take the square root of this side. That's interesting. That will undo the squaring and avoid the having to use quadratic formula. It's very counterintuitive, or at least it should be, for those of us that are well trained with quadratics, but this is a nice little shortcut. Now, the square root of 40,000, that must be 200, because if I double 200, I get the 400, and then I multiply the 100, I get the 40,000. So this is 200. But remember, we're looking for all of the solutions. So this isn't, we weren't presented with the square root. We introduced the square root, so we'll take advantage of this symbol, plus or minus, meaning we want both the positive and the negative root of this. And then we'll add the 2,000 over, so we get x equals 2,000 plus or minus 200. So one of the solutions, obviously, is 2,200. Or 2,200, I should say, since I'm a mathematician. And then 2,000 minus 200 is going to be 1,800. And those are the solutions to the equation. And we avoided quadratic formula. That was nice. Let's try our hands at a situation where we want to solve for one of the variables given, but we're not given values. So we're not given any values, but we want to solve for z. Well, the first thing I do, since there's a negative in front of this term, I'll move it over here and move that over there. So I'm going to move the 3z onto the left side so it's positive, and move the 1 over x over here. Okay, I'm solving for z. So it says solve for z, so I don't want the negative in front of the z. That's awkward. Now I'm going to multiply everything by z. So I'll multiply this by z, and this by z. Well, that gets rid of this, and I have a 3 here. Over here, I have z over y minus z over x. Now I'll multiply everything by x. Multiply him by x, and him by x. The number one mistake is you just multiplied one term over here. No, you have to multiply the whole side by x, so that means that x distributes to all the terms. So we get 3x equals zx over y, but here the x is canceled out minus z. Well, obviously what I'm going to do next is multiply by y. And like I said, you're multiplying y by the whole side, so you get y times this and y times that. So we're going to have, and then I multiply this side by y too. So I get 3xy equals, now when I multiply this y by this, it's zx. But when I multiply by the z, I get zy. Now, I would like to add up all these z's, but they're dissimilar terms. You can't add dissimilar terms, but what you can do is, what's our favorite F word? That's right, factor. We can factor out a z. And now I can divide both sides by x minus y. So I have 3xy over x minus y equals z. Now, I have just done something. If you divide by a variable term, that variable term cannot equal 0. So I just put a condition that wasn't there before. See, originally x cannot be 0 because if so, it would be in the denominator, that would be undefined. Y cannot be 0, and Z cannot be 0. But now, since I divided by x minus y, I've added the condition that x minus y can't be 0, which means if you add y over, x cannot be y. So that's interesting. Okay, if x is equal to y, then we'll get 0 on this side, and then you'll get some product over here, and it just won't work. So it turns out that x cannot equal y. So that was kind of tricky. So you have to be careful when you divide by a variable term like x minus y that you don't divide by 0. And the only way I'd be dividing by 0 is if x and y were the same numbers, so that x minus itself would be 0. So that's why I had to do this over here. But other than that, that wasn't so bad. Math made simple. Simpson math.